Ding. Alright. Microphone appears to be working. I cannot plug that into the USB port, or the hub. Hello, 3 people. Oh gosh, of course Tribble's back. Who told you? That's probably Warren. Yeah, I called that even before it happened. Oh, you sent an email to me. Oh, yeah. No, it's happening. We'll see how many people show up. I forgot to put the time on the calendar, so people just had what I said in class. Oops, really on top of my game this time. Alright. So it is 7. I am still recording. It says it's on Monday. Does it? Here, I can check that. What do we got? Yeah, it didn't say when it was, so I'm in the clear on that one. Oh, it says it on Monday and it says it on Friday. I just updated it on both. Well, hey, we got 9 people here. That's pretty good, all things considered. 12? Alright, yeah, alright. One of them's TJ, so that's useless, but otherwise, let's get rolling. So I am going to start off by going over the quizzes because, well, let's look at the results of those quizzes. So, yeah, these are the results of the quizzes. So, can I make this look big? Overall, not so great. We're looking at like C and D averages in the quizzes. So if you're wondering why your grade went down, it's because a lot of people's grades went down. There were a handful of all 5 people, but they were mostly in the periods that did better. The quiz difficulty was relatively balanced, but there was some trickier stuff if you like get rattled with logarithms or struggle to solve for values in trig functions. There could be some problems there. Yeah. Interesting trends in that data. Alright, so let's start with the quizzes. Oh, and Will, you were one of the people who got all 5, so congratulations on that one. Let's start on quiz number 1. So I'm going to go over all 4 quizzes, so this is going to be very exciting. Just make sure my mic's still working. We're good. Alright. Alright, so first quiz. Now this first section threw people for a loop, so I'm hoping people who bombed this watch this stream so that they know how to do this. First thing in the first problem is that 13 goes between 11 and 15. And so when we're trying to find their slope, we're going to use those 2 points. Now our 2 points are 11, 14 and 15, -20. Some people struggled with writing down the points. So these are y values down here, and these are x values up here. So I do y2 minus y1 over x2 minus x1. And in this one, I got -34 over 4. And that's good enough. You could simplify that, because it simplifies to like -8.5, but you don't need to. In our second one, we get 7 cubed minus 11 is y2. Minus 5 cubed minus 11, which is y1. Plugging in 7, plugging in 5. I can put parentheses around this to make it clearer. Over x2, 7, minus x1, 5. And that's a good enough answer. You could have simplified this, and I believe it simplified to something reasonably nice, but I don't care. That's good enough. All right, for limits at a point, a lot of people went, oh my gosh, it's 0 over 0. That's undefined. That's not true. 0 over 0 is more work. So we're going to do that more work. We're going to factor that top to x plus 1 times x plus 2. If you take the 3 out, you get x squared plus 3x plus 2, which factors very nicely to this. And on the bottom, you get x minus 9x plus 2. And the x plus 2's cancel at our whole, which was negative 2, and at our limit. And so now we can plug negative 2 in. And so we get on the top just 3 times negative 1, or negative 3. And on the bottom, we get negative 2 minus 9, or negative 11. And so negative 3 over negative 11, or 3/11 was the good answer there. In our next one, you were plugging in values. So 0 into cosine, 0 into sine. Those don't match. Cosine is 1, so this is 2 at 0. And sine is 0 at 0. And so 0 does not equal 2. This one was garbage, undefined. Pi over 2, I just plug it into this sine function. Sine of pi over 2 is 1, so that's just 2. And if you plug pi into tangent, sine is 0 at pi, which is the top of a tangent. And so this thing is 0. Whoops. It's 0 from the right side. And if I plug pi into the 2 sine x, it's also 0 from the left side. So that confirms it's 0. It's 0 in both equations that it attaches to. All right, that's the first two. Let's pop out and check the questions. How do you integrate? Oh gosh, Jay Beeman, Dan Noble. Oh, this is awful. Kennedy, I'm in the middle of a restaurant watching this. Am I dedicated or what? Yeah, that sounds dedicated. Also, I feel bad for the people in the restaurant. All right, let's move on to the second half of this first quiz. In this one, f of g of x, a lot of people are having a hard time like plugging things into functions. Remember, you're plugging g into x for f of x. So I'm plugging 5x squared where the x is. So this is 5x squared to the 1/2, which is the same as root 5 times x, well, more like an absolute value of x. And the whole point is that thing is continuous. If you force the inside to be positive, you can square root it. And so this guy was all real numbers. In our second example, it was 1 over x squared minus 4, because you plug in x squared plus 107 onto the bottom, and 107 minus 111 is a negative 4. Now that you have this bottom factors very nicely to x minus 2, x plus 2. And so we get x equals 2 and x equals negative 2 as two problem spots. So I'm going to say x is not equal to 2 and x is not equal to negative 2. And that would work. If you're not happy with that, you can always do the interval notation, negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. And that also works. A couple people gave that answer. That's good. In our last one, we're plugging x squared minus 1 in on the bottom of this fraction. So I get 1 over natural log of x squared minus 1. And maybe you didn't have this quiz in class, but this is a really good question, and this one foiled a lot of very smart kiddos. The problem is you're not allowed to put zeros or negative numbers into natural log, and so you only put in 0 or negative numbers when this term is smaller than 1. And so, because it's a squared term, it's only going to go between 0 and 1, so I got to find the range where it is between 0 and 1, and that's just from negative 1 to 1. Anywhere in that range, that squared minus 1 is going to give me a negative or a 0. And so that's the garbage range, and so if I was giving interval notation to the answer, I'd say from negative infinity to negative 1, and from 1 to infinity. So I had a fair number of people get this answer, but forget the negative version of the answer. All right, and then we move down to our limits at infinity at 0 first. In this one, this one was rather nice in that if you plug in 0, you get 1 over 4, because cosine of 0 is 1, and 4 is 4, and everything else is 0. And so that one was rather kind. For our 4.2 example here, the power on the bottom is x to the 4th, the power on the top is x to the 5th. Top wins, we go to infinity, because we're going to positive infinity. There's no sign problems here. And so those ones are pretty easy if you get all the tricks on them, and pretty brutal and mean in the grading if you don't. All right, that was quiz 1. Let's go check out the questions. Will there be limit questions with union answers on the test? Yes. Okay. You'll learn it next unit. Oh, what are we learning next unit? Alright, let's move on to the next quiz. Looks like the trolls from last year are still spamming chat. Thank goodness for that. Alright, second quiz. In this quiz, 2 was between 1 and 3. Oops, I didn't go to screen sketch. Let's try that. Alright, so 2 was between 1 and 3. So I do negative 91 minus 11 over 3 minus 1. And honestly, folks, I'm happy here. If you can get to this spot and not go beyond this. I can't tell you how many people got this answer, which is negative, 102 over 2, or negative 51. And then they were like, oh, I gotta add that to 51 or something, or 11, and they got negative 40 as their answer. No. We're not estimating a value. We're estimating the slope, which is what this equation does, this slope equation. We don't know what curve this thing looks like, but what we've done here is take 2 points, find the slope between them, Alright, it's back, guys. I don't know why it keeps freaking out. Can somebody verify? Because it's showing up on my OBS now. It's been muted for so long. Ugh. Restart, please. Time to restart the quiz. Seriously? It was out for the quiz? From question 2. Alright, thank you for that. Alright. Let's zoom this out and try to do this a little more efficiently. And hopefully my... I need to do this next to my computer so I can see when something goes wrong. Anyways, hopefully 2 made sense. Like, this one's just a, you gotta factor this sort of thing. And I factored this guy in the previous iteration. That didn't quite make it. And when you cancel those, you're allowed to plug -1 in, and you get to the answer. Now, I'm happy to talk through 2-2 here. In 2-2, you plug 0 into both of these functions, because they're the ones with zeros in their domains, and you get 0 in both of them, and so we know our limit at 0 is 0, because those match. Now, we plug in pi over 2 into both of our functions. Pi over 2 plugged into the sign gives me 2, because pi over 2 is 1, and times 2 is 2. And when I plug in pi over 2 into tangent, I get garbage, because you can't divide by 0. Cosine of pi over 2 is 0. And so I get 2 doesn't equal garbage, and so this one's undefined. And then for the last one, I plug in pi, and tangent of pi is 0, so this is 0. And that was that set of answers. Hopefully that talk through helped. For our next one, it was the square root of 4x. You gotta be bigger than 0. You can't be equal to 0 here. Because if you're equal to 0, you have nothing to the right in the square root function. And so there is no limit, because you have to have a limit from both sides in order to have a... for the function to be continuous at a point. So square root's continuous everywhere to the right of 0. For our next one, if you plug this function in, 1 over x cubed minus 8, it's just x equals 2. That is your problem. And in 3.3 here, you plug in natural log of x, you get 1 over natural log of x squared plus 1. And natural log's a problem, so you got to be bigger than 0. That's natural log's deal. Natural log of 0 doesn't even exist, unlike square root of 0. Alright, before I move forward, let's make sure my mic's still working. Let's pull up OBS. It's still working. Seems good. My parents want to come to dinner. I'm watching... Oh, God. Invest in a better mic? My mic is fine, dude. Hater. Alright, let's go down to question 4 here. So in 4, the key idea was just to plug in 0, and you get 1 over 4. Every other term is 0. That's that guy. For 4.2, the square root of x to the 8th is x to the 4th. In an absolute value, but x to the 4th is already positive, so we're chilling. And the dominant term on top is the x to the 5th. It's the biggest terms in infinity. And so bigger on top means we're going to infinity. And we're good. That's that section. I love limits in infinity and 0. It's very quick if you know what you're doing. All right. That's that guy. Where is the Hearthstone stream? Yeah. All these Kennedy haters. Yeah. What are you gonna do? All right. I'm gonna pop through and look at the interesting ones. So this is the 3rd quiz. You should do the same thing that we've done in our other talks here, except between 15 and 17. So 11 minus a negative 20 over 17 minus 15, which is 31 over 2 or 15.5. But again, I'm really okay with this answer. I want to see you like actually doing y2 minus y1 and stuff. All right, in our next one, we did an example like this in class. Natural log of 5 plus e to the 5th minus natural log of 1 minus e to the 1, that's y2 and y1 over x2 minus x1. And you can bail here. This is good enough. A lot of people did some demon magic, like e to the 5th minus e is e to the 4th. That's not true. That's really not true. If you divide, maybe, but not subtraction, so don't do that. All right, for our next one, limits at a point on top if you factor. Now I'm factoring. A lot of people didn't factor because they plugged in -4 and they were like, oh, it's 0 over 0. I don't have to do any more work. But we know now that there is more work, and every single one of these required some level of factoring. If I factor the bottom, I get x plus 6, x plus 4. I kill those guys, and wow, if I plug -4 in now, I no longer get 0 over 0. I get -8 over 2. Or -4. All right, if I plug 0 into these two functions, I get 0 and -13. Those don't match, so this one's garbage. It's undefined. Next, I plug pi over 2 into sine. I get 1. I plug pi over 2 into this. I get e to the pi over 2 minus pi over 2, which is 0. And anything to the 0th power is 1. So these dudes matched at 1. And for our last one, at pi, you just plug pi into the e function, and you get e to the pi over 2. And we're good. All right, on to the second part. We hit 100 subs. Wow, I'm honored. It's like I have moderators in chat here. All right. So for continuity here, if I plug this guy into here, I get x plus 2 to the 1/3. And 1/3 powers, I can plug anything I want into. If you remember a parent graph for the third root, it looks something like this, which is chillin'. We can do anything we want, so this guy was all real numbers. For 3.2, we have a squared, so all of a sudden we're unhappy with things. But square roots are where the problem is. Our only real problem here is we got a 0 on the bottom. We can totally make this 0. It's just wherever x squared equals 111, we're going to have a problem. And that's at x equals root 111 and x equals negative root 111. A fair amount of people forgot the negative guy there, but you need both. And so, again, just like the 2 quizzes ago, I'm going to say x is not equal to those. Those are the problem areas. That's where this function is not defined and has asymptotes. For our last one here, we plug an x squared minus 3 into a natural log, so this one also had a natural log conundrum. I'm not allowed to put 0 in here, so 0 happens at root 3 and at negative root 3. And just like the other one, I need to have my natural log be positive, and so it needs to be either smaller than negative root 3, so negative infinity to negative root 3, or from root 3 to infinity. Both of those are cool. All right, down to our bottom one. Smallest power on the top is 2x, smallest power on the bottom is 3x squared. If I divide those, I get 2 over 3x, which is a 1 over x sort of dude, which if I plug in negative, really small numbers, and positive, really small numbers, I get different answers. I get positive big or negative big, and so this is garbage. They're approaching different values. And for our one on the right, if I plug infinity into my largest powers here and here, these are the guys. Whoops, that's not the guy. It's x to the 5th. On the bottom, I get x to the 2.5. On the top, I get x squared. 2.5 wins. This is going to 0. The bottom power 1. Remember, square root means half power, and you multiply half by 5 to get the power on the inside. Let's go back and check. Yikes. Okay, mic's still working, so those yikes are maybe get their Nico kneecaps. Okay, Dan, I mean, honestly, be nice. Can you do 10 and 11 on the homework worksheet? I absolutely can. I want to take a peek at quiz D, the last one, just a quick one, because a lot of the answers end up being close to the same. In this, if you plug 1, and people in this class did very not awesome on this first one, I remember from grading. If you plug 1 and -1 into this, you get 12 in both of them, and so this was just 12 minus 12 over 1 minus -1, which was 0. A lot of people missed that idea. In this bottom one here, I threw a little curveball in that when you factor this, a root cancels, but it doesn't cancel at the limit, and so we end up still getting 0 over -10, so it's 0. And you could also just plug a -4 from the get-go in that one. So every other one you like had to factor, and in that one you didn't. Otherwise, the problems are largely similar. It's worth going over the infinity ones just because people get wrecked on those usually. So I'm going to go over a couple at the bottom there. If you plug 0 into this function, you get 1 over 4x cubed. Well, those are my smallest power things. This is a 1 at 0, and this is a 4x cubed. And 1 over an odd power is the whole, like, this sort of deal. On one side it's going to infinity, on one side it's going to -infinity. So this is garbage. In our other one, we have an x to the 3/2 on the bottom as our biggest power. Square root of x cubed, and an x to the what squared on top. That guy wins. And so this guy was going to infinity because the x squared won. If anybody has any other questions on that quiz, Hello, okay. When did my mic turn off? Watch it on your phone, Kennedy. Yeah, I know, right? What did I lose here? Jaboosted is good. Before the problem? Oh my god. I don't know what's the problem, because the problem is my USB port on my freaking Surface Pro here, which is extremely frustrating. I wonder if I can just hard plug into audio jacks on this thing or something and avoid this problem, but it doesn't have a mic jack. Okay, okay, whatever. Let's talk about 87 again. Significant regret. All right. So in 87, hopefully you got that I got common denominators and saw that piece. That is the trick in this one is to multiply by stuff that gives me common denominators and multiply by stuff that gives me common denominators. And then stuff cancels out, and the top looks like x plus 3 minus x minus delta x minus 3. And I talked about this, but you couldn't hear me, that the negative distributes to all those terms. And the bottom stays a janky set of nonsense. But the beauty of this is the x's cancel, the 3's cancel, and I'm just left with this negative delta x homie, which I divide by this, and I get negative 1 on top. And then you're totally able to plug in 0, so your limit, and you don't get a 0 on the bottom of the fraction because you canceled it, and so you get 1 over x plus 3 times 1 over x plus 3, because this becomes 0. And that's the answer for that one. Hopefully between the two, the longer, quieter way and the quicker, louder way, there's something learned. Alright. Let's burn all Microsoft products. Yeah, Surface Pro problems. Alright, microphone seems to still be working, so that's fantastic. Surface sucks. Well, it might be my headset. I don't know. Headset's a little old, but it's pretty awesome. It has great sound quality. Alright, let's go to the new homework and do those questions that somebody was asking about. I don't even remember at this point. Jordan, there we go. 10 and 11, there we go. Where is that worksheet? I know I put it on here. There it is. 10 and 11. Oh, did I not give this one? Oh, crud muffins. I don't see 10 and 11. Jeez Louise. I see an 11. 10 and 11 on the first page or the second page? 11 is in the gray box. Oh man, I'm tilted. It seems like I changed the worksheet for last year. Well, I have an 11 here, and I'm pretty sure this is the same one. Oh, on worksheet 1.5, I'm on the wrong worksheet. Alright. I get it. I'm going crazy here. Come on. Where's 1.5? Alright. Is this the right worksheet? It's on worksheet 1.5, Mr. Kennedy. Alright, we dropped and tilted. Oh gosh. Is this the right spot? 11 on this worksheet? Yes. Okay, cool. Alright, 10 and 11 on here. Show that something is continuous. If they tell you to show that something's continuous, what you're looking for is, do either of these functions have problems with continuity? And the answer is no. Trig functions keep doing their thing. Exponentials keep doing their thing. There's no square roots, natural logs, fractions, any of that sort of garbage. Second thing we do is we check to see if at 0 they match, which is what you do in that limit at a point section when I give you a piecewise, like all the time. So you plug 0 into this and you get 1. And you plug 0 into this and you get 1. And you check, those match, and so this thing is continuous everywhere. So that's the check there. Oh my gosh, my handwriting. 11 on here. I plug 2 into x in both spots. Same idea as what happened above, and same idea as a lot of people should have done on the quiz. And you get 4k in the top one. And in the bottom one, you get 4 plus k. Again, I'm plugging 2 in for x, because that's where these functions meet, and I want to make sure they meet so that it's continuous. Then you just subtract k from both sides. You get 3k equals 4, and you divide by 3, and you get k equals 4/3, and you're super happy. That is the value of the coefficient of the x squared and what you add to the 2x to make these meet at 2. These are archived, right? Yes, they are. Can you do 15 and 16 on the chapter 1? Yeah, I will go there next. 13 and 14 too. Alright, I guess we're just doing a big stretch of the review worksheet problems. Oh, darn it. Stupid word. Here we go. Alright. Okay. It's like the one moment I regret not putting the questions in order. So I think 15 and 16 were my first questions? Yeah. Alright. So, for 15 and... Oh gosh, that's not the right question. That's a problem from last year. For 15 and 16, I am doing that same trick I've been doing for like so many of these problems, where these two guys, I got to check to see if they meet at 0. So I plug 0 into both of them, I get 0 in both of them, so I'm like, yes, 0 is chill, it's cool. Then I plug 1 into both of these two functions, because they're the ones with 1 in them, and I get 2 minus 1 in one and 1 squared in the other, and those indeed match. Those are both 1. So that one's Q. So 0 and 1 are both in the clear. These functions meet at them. And lastly, I plug 2 in here and 2 in here. Here. And I get -1 in the bottom one and 0 in the top one. And that's garbage. Those don't meet. And so 2 is a significant problem. And so 2 is the spot where we are not continuous. So really, it's this checking the limit from both sides thing that is the main skill in so many of these. 16 here, the vertical and horizontal asymptotes of this function. Well, first of all, the power on top is 1/2, and the power on the bottom is 1. And so if we go to infinity, the bottom is going to win because x to the 1 is bigger than x to the 1/2. And so we have a horizontal asymptote at y equals 0. So that is one thing we got going for us. And then the other thing we got is vertical asymptotes. That's where the bottom is 0. And so that's at x equals -4. And so it's like, booyah, there's 2 here. Let's check back and make sure my mic's not muted. OSU stream. What? OSU? That's garbage. Oregon State. Is he using an OSU tablet? An OSU? Oh, some garbage. No. I'm using Surface Pro. The test is not tomorrow, people. It's Tuesday and Wednesday. So, depending on which day you got, A day is Tuesday, B day is Wednesday. And yeah, Naira, I'm going to go back and look at 13 and 14. Oh, gosh darn it. I just closed it. Alright. 13. Where... Oh, on the other worksheet. I'm chilling. All right. Apparently people had more problem on that 1.5 worksheet. All right. In these, all you're doing in every one of these is plugging in k the second you can. And 13 is an example of one where you cannot plug k in right away, because we have to account for the whole, which is, if you factor x plus k, x minus k over x minus k. These cancel. Now you can plug k in, and you get k plus k for that top term. For the bottom term, if you plug k in, there's nowhere to plug it in. You just set k plus k equal to 9. And this will make these meet. Because, I mean, functionally what this is it's the linear function x plus k, except it has a whole at x equals k, which we know already because it said it's this thing for everything except k. So we are plugging the whole. This is the value at that whole point. And so this equation is really easy to solve. 2k equals 9, k equals 4.5. And that's that guy. For 14, it was a bit of a step problem. First, you had to plug -1 into both of these dudes and get -1 plus 5 equals negative k minus 7. So I just plug -1 in for x in both. And you solve for k. It's pretty easy. It's 4 plus 7 is 11 equals negative k. So k equals -11. And then you plug 2 into the bottom two equations. I guess I have to plug in twice in that bottom one. And you get 2k minus 7 equals 4 minus 2m. But we know what k is already, so we get -22 minus 7 equals 4 minus 2m. And we can solve this. So it's -29 equals 4 minus 2m. So we get -33. All right. The funny thing about this mic issue is that it happens at really weird times, and I'm not sure what's going on with this. I don't know if I need a new mic, though. Hopefully I didn't lose too much there. Can you guys tell me? I checked it pretty quick. All right, I got a question from Nikhil. It looks like, how do I do limits with trig in both the numerator and the denominator? All right, seems good. I can do that. That's what it feels like to be a 17th century Catholic. No, that's like not eating dinner. That's more that. You solved the top two. I'm very confused. All right. Let's erase all this garbage from last year. Oh, just dump it. There we go. Okay, so if you have a problem with trig, I did solve the last two on every quiz, and there were a bunch with trig in the numerator and denominator. But oh my gosh, does it matter what is in the denominator and numerator when you're evaluating trig functions? So if you have the limit as x approaches 0 of x cosine x over x squared, this guy is going up like this on this side and is going up like this on this side. This power is bigger than this. And so even though this guy has a trig function that's making this thing go crazy, it's going to get neutered by this x squared thing. And actually this graph is really bad. It looks more like this. But it's still getting neutered by this x squared, and so this guy would be going to 0. If I had limit as x approaches 0 of like tangent of x plus 4 minus 3x plus x squared over 4x minus cosine of x, this is another pretty easy case because you can just say, hey, I know tangent of 0 is 0, so this is 4 on top, and I know cosine of 0 is 0, so that's 1, and I get 4. So those are like the easy cases where something wins over the other one. And I'm going to double check and make sure my mic's working. And it is, so we're cool. Rip, it got neutered. What? 13 on the AP rip sheet. Rip, what? Oh, okay. Somebody's mom walked by. Are the vertical asymptotes on the top or the bottom? Bottom always. It's where the bottom's 0. It's why that breaks math. Let's go back and look at a few more examples of the trig thing, and then I'll go to Naira's question on the worksheet. So, the trickiest cases are where you have something like 4 plus 6 sine x over, let's see, like cosine of x plus 3. This is a tricky limit as x approaches infinity. And the reason why is both the top and bottom are relatively abstract. My favorite trick for this is to think about this bottom as, since cosine is going from -1 to 1, I like to think of the bottom as going from 2 to 4. On the top, because sine goes from -1 to 1, this is going from -6 to 6, which means the top is going from -2 to 10. And something going from -2 to 10 divided by something going from 2 to 4 does not converge to anything. And so this would be some garbage. Even though we're not dividing by 0 here, because our top goes negative, it means this thing is oscillating down to negative and then up to positive and doing some janky garbage. And this guy is not approaching anything. And so you really have to think about what the trig functions are doing to your function. In the case of something like a tangent at infinity, you almost always know that the tangent is going to ruin things at infinity, because tangent has asymptotes. Oh god, that's a horrible tangent graph. It looks more like this. And these asymptotes destroy things. So tangent is often a freebie, but we could do stuff to like neuter a tangent or that sort of thing, and it would change the scope of the problem. So for every trig function, there's no like hard and fast rule. It's not always undefined because there's trig. The classic example is to just go to infinity with like cosine of x over x squared. And the x squared is going to beat up the cosine of x, and we're just going to go to 0. Even though we go through the asymptote, we end up going towards the asymptote of 0. All right, let's make sure my mic's working. It is. Feels good. And Dylan's here. Oh, thank goodness. All right. Just explaining trig limit things. Yeah. All right, let's go back to Naira's question. 13 on the AP review worksheet. That's what I want to do. All right, AP review worksheet. That's one of my ones here. Problem was 13. Okay, it's just the bottom. Big guy. Yeah. All right, so this question, mostly just difficult because of the wording. Oh, it's the intermediate value theorem question. All right, so this is way easier. Okay, if we're doing 13, the intermediate value theorem problem, we have made life much easier for ourselves because intermediate value theorem is really easy. All right, so all you do is you plug in 1 and you get -1, so 1 comma -1. And you plug in 2 and you get 16 minus 3, which is 13. So it's 2 comma 13. And you say, yo, dude, this guy is continuous everywhere. So IVT says we need to go from, through everything between -1 and 13. And that's the big idea. The point is, if it's continuous, it goes through all these values, and we're good. And so intermediate value theorem is super family friendly. Plug in the points, make sure that the y value you want is in between those points, and make sure the function's continuous, and then just say it goes through them. That's it. Let's see if that answered the question. Message retracted. I forgot what that freaking theorem is. Oh, yeah. So, yeah, it's a pretty nice theorem. Would you do C and D on the next problem? Heck yes. All right, let's do it. Yes, this goes a little above and beyond where we've gone, because it says there's an end behavior function, and we've kind of talked about this. It's basically end behavior is the limit at infinity. And if I'm looking at the limit at infinity, what I care about is the biggest power functions, x cubed over 3x squared. And what it's saying is there's a function that looks like this. If it looks like the ratio of the two biggest power terms. So I divide these, and I get x over 3, because the x squareds cancel. And so this is what this function looks like as it goes out towards infinity. It looks like a linear function with 1/3 slope, because the power on top is just winning by 1 over the power on the bottom. And that's that. In behavior model is also like, hey, it's going to infinity. It's just going to infinity at this speed, x over 3. For the limited infinity part, well, we already answered that part. It's infinity because, yeah, if x linear functions go with positive slopes, go up forever. And then what's the limit at infinity if you divide the original function by this function we just made? Well, the function we made is the, like, basically the asymptote function for our function in our problem. And so these guys are going to get really, 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 really close to being the same as we go to infinity, because that's why we made g, is to be what f looks like at infinity. And so these are going to be 1 if you go out to infinity, the ratio between this. And that's what that stuff meant. Good review for cruisage. Yeah, probably, actually. C and D under 13. I definitely did that, so... What do we got? I got like 5 minutes. If anybody else has any other questions. What kind of stuff beyond the tests? The stuff that I brought that is going to be on the test that people haven't really talked about, well, put on my little desktop area here, is one thing I guarantee that maybe you don't remember will be on the test is completing the square. You need to know how to complete the square for the test, because this is on there. And additionally, oh, crud muffins, my parent function thing is not in this. So you need to know the parent functions. I'm going to make you sketch parent functions. So those are the things above and beyond what we've quizzed on. Otherwise, everything on the test is stuff we've quizzed on, or it's like the worksheets we've done in class, especially the last couple, like continuity or limits at infinity, or crossing out holes, or doing analysis of piecewise functions. Those are the skills that will get you to where you want to go on the test. Let's get a Discord server for AP Calc. So honestly, Nikhil, I've really thought about doing that. Can you post the list of concepts on the Warren, buddy, it's like everything we've done. guys, it's point 1 through point 8 and 1 through 6. Although power function 6 specifically is only used to check your answer and limit definition. It's like everything. Can we get a guide on how to beat Questro? Yeah, rush them down, idiot. God. Anyway, sorry if any parents are walking by. I'm trolling somebody on video games stuff. Completing the square example problems. That would be a great final problem for the night. Guide on how to climb the Challenger. I don't play League of Losers. Path of Exile stream. Oh, we have one Path of Exile fan in here. I played way too much of that this week, and I got like 20 hours. I'm trying to get some mirrors and stuff. All right, anyways, back to When I unplug it and replug it back in, we're good. When did I lose it? Rip mic part 4. There it goes. Not before the example problems, though. I gotta figure out this problem. I'm sorry, guys. Can I talk about... Maybe I can talk through this problem? Hey, so folks, in case you were missing it, I divided this... I always factor out the coefficient of x squared first. You don't have to. There are other methods. I always divide the b term by 2. I always rewrite that as x plus 3 squared, figure out what x plus 3 squared is. I make my equation now with x squared plus 6x plus 9, which I know is x plus 3 squared, match my original equation. So I did that by doing 100 thirds minus 27 thirds to get 73 thirds. And then I took the 73 thirds out, got a 73 on the outside here, and wrote my answer finally in the x plus 3 squared form. Remember, you can always check your answer to see if you did this right by expanding this out and making sure it matches. And sure enough, if we expand it out, we get 3x squared plus 18x plus 27 plus 73, which is 100. And so you can always check your answer when you complete the square. Sorry again about all the mic issues. I really... I can blame Kennedy's mic if I'm sorry, guys. I will try to figure out my mic issue before the next video so that it's more useful than this one. I don't think calling the mic company is going to handle or do a lot, Carter. Sennheiser's a pretty good company, and my mic. I use this like game with my buddies, and so it works well in my computer. It's the USB port on my Surface Pro that I think is the issue here. And good night, y'all. I'm going to end here. Those of you that have class, we're going to have more time to talk about stuff related to this. But those of you who don't, see you for that test that I've totally written. I've written only one version of it. So, is it gamer time? Yes, it is indeed gamer time, Sam. I'm going to go play games. All right, bye-bye.